So I thought of coming up with these kind of sessions frequently. So we'll be meeting through the virtual mode of this WebEx platform, and we'll try to leverage our learning progress. So whatever I'm trying to upskill on relevant to the data science related concepts or the technologies, I'll be coming up with a session. Since you all are aware that my profile is all about a training, so I would like to come up with this kind of a channel to be interacted with you people. So this I was having as a plan for a long time, but I didn't get the right channel to start up. And now we are on the pandemic modes. Probably you people might be working from home, or you'll be people who are in college, or you might be staying at home. So I thought this would be the right time for us to connect up, and then we can try to enhance the skills that we are progressing towards accomplishing this data science profile. So okay, with that as a context note, so what is the plan that I have? I'll try to sketch it out. So it's just 1.5 hours of time, so I'm not going to take you through any theoretical explanations here. My way of approach here is going to be completely of practical. So you can catch it up with the theory later, okay, and you can go with the practice work also later. But lively you cannot practice, since we are on virtual, so I cannot wait for your turn to do your practice simultaneously, which is practically not feasible. So we will go ahead with a live learning, and post that you can go back and recall all the learnings and then start practicing it. And we always there on the group, so you can connect up with me on the group virtually, so that if there is any queries you have, we will further have the group to be utilized for the communication. Okay, so the agenda here, you are right now seeing my Jupyter lab. uh, I guess you are able to view my screen clearly. So this is a Jupyter lab. It's not Jupyter notebook, okay, it's a Jupyter lab. So I advise you to use Jupyter lab because it has more vibrant environment here. As you can see, it gives more convenient way to access the file folders and everything. You can have some theme settings. So it's quite reasonable to have Jupyter lab rather than Jupyter notebook. But if in case you don't have Jupyter lab and you own only a Jupyter notebook, nothing wrong in it. You can go ahead and make use of the Jupyter notebook itself. If in case you don't have the Anaconda installed in your machines, or you don't have notebook, or you don't have Jupyter lab sitting in your own mission, then you better go for Google's Colab. Okay, I think in the group I've already referred the Google Colab. Okay, you can make use of the Google Colab virtual notebook, Jupyter notebook. There you will have the complete setup for working with NumPy, Pandas, or you can work with Matplotlib, Seaborn. So all these libraries are available on the Colab. You need to log in with your Gmail credential, and then you will have your own virtual space where you can start creating your notebook. Okay, so these are the different channels in which you can start working with this library. Okay, great. So why NumPy? Why is that I've chosen NumPy as the first training session for our group? The reason is NumPy is the way we have to start in terms of applying the uh, Python functionalities when it comes to data science. Okay, the first thing that we have to start learning is the NumPy, because the NumPy is going to give us a numerical application implementations uh, in a data science field. So that's the reason I've picked up NumPy, and I'm closely working with NumPy. As you would have seen that I've shared my notes also, I'm rigorously working on it to enhance the high-end skills on NumPy. So it requires multiple other prerequisites. So let's take some of the prerequisites that is a need when it comes to NumPy. The number one requirement is you need a bit of mathematics skills. Okay, a basic mathematics skills. Number one, math skills are required. That's why I've started to float frequently math and statistics related references on the group. You would have noticed that. Okay, so we need the math skills. Number two, the statistics skills. Okay, that is required. And by having this base fundamental skills of math and statistics, we can go ahead and work confidently with NumPy. But do we need to excel in NumPy in order to work with data science? If you have such question, ideally not. You don't need to go in depth to NumPy. Okay, you can have some 40 to 50 percentage of the skill on NumPy. Okay, we need to acquire 50 percentage of the skill minimum in order to start our journey towards data science. So not required that you have to hard learn the NumPy module. So it's good if you have the 50 percentage of skill. That is mandate. In continuation with NumPy, you will also go with Scifi, which is a scientific Python, where they will give more advanced formulations for statistics and mathematics. We have another library called Scifi. Okay, and in continuation with, you can go with Matplot skills. Okay, Matplotlib, and then in what actually happens in Matplotlib is we bring out the visualization. Okay, so you might be having some set of datas in hand. You need to pull out the datas. When you're pulling out the datas, you will use the NumPy to apply some functionalities on top of it, on top of the data that you've pulled. And you will use the visualization tool, that's nothing but the Matplotlib, to bring out your charts. Okay, you want to display a chart, right? Different types of charts for, let's say, for example, normal distributions. Okay, in statistics we have one of the important distributions called now normal distributions, binomial distributions. If you go with such standards of data managements, we need to visualize those data. So for that, we need to generate different charts. So there we go for Matplotlib, and in continuation with that, we will also go with pandas. Okay, so pandas are nothing but panel data. So it is called as panel data, right? Panel data. So a panel data is predominantly used in data science. That is, pandas are predominantly used in data science. It's a Python library again. So we start our journey from NumPy, then we go with Scifi, Matplotlib, and pandas. Okay, so this is my focus right now. So we'll see how far we can frequently connect up with these kind of virtual mode, and then we'll try to learn more things, and then see we can quickly enhance our skills on all these platforms. So I guess so far it's good. There is no problem in my voice or on the video. Please let me know if in case you have any challenge. What are
Sure, sir. We are able to hear you.
Yeah, sure, thanks. So please do convey this on the chat. Okay, you need not come on audio. You can just chat through the chat box. And yeah, basic mathematics. Yeah, equations. Okay, algebra, linear algebra is something very important. Okay, you have to focus on linear algebra, because NumPy's base library functionalities will focus on linear algebra. Okay, so you need to focus on linear algebra, statistics, probabilities. When it comes to statistics, as I said, probabilities, you need to have some knowledge on probabilities. Okay, those areas are very essentials. Okay, and some of the basic fundamentals of statistics, like distributions. Okay, data distributions in terms of normal distributions, binomial distributions. Anyways, I'll talk about this probably statically on the group, so we don't need to spend much time on that. Let's go straight into the topic. Okay, so the first thing that we have to do here is NumPy have to be imported. By default, it's available in Anaconda, Anaconda distribution. So if you would have installed Anaconda, you would have seen that the NumPy will be there. Okay, then Matplotlib will be there. These are by default libraries which are integrated in Anaconda distributions. So you can go straight into your Jupyter Notebook or Jupyter Lab, and then go for importing your NumPy as NP. So what I'm doing here, I guess you all would have skilled up right by now on Python. So at least the basic scripts you might be aware of. So I'm importing the NumPy, which is a NumPy library. And this NumPy library uh, is going to be aliased with NP. Okay. So it's just an alias name. And this alias name is going to be used throughout the course as NP. Okay. A shorthand form of NumPy. This is the first step that you have to do in order to import your NumPy library. Import NumPy as NP. Good. So let's go to the new cell. So let's not touch this cell anymore. This cell is exclusively for importing the NumPy. We have done that. Moving to the new cell, I'm going to use, I guess, recently, some 3 days or 4 days back, I would have shared a piece of code on NumPy related, I'm sorry, on list related, array, Python list related, and I told you to convert them to a NumPy. So I've also done that, and I've forwarded that code as well. We will work on that. Why we need to work on that here is because we need to understand that why we need to go for NumPy. Why is that we need to go for NumPy? Okay. So what is special in NumPy? That we have to learn first practically. So that code can help us in understanding this. Two major thing happens in NumPy. One, the performance is pretty good when compared to the traditional Python list data structure. If you take one of the data structure in Python is list. Okay. List is one of the Python data structure, and compared to the Python data structure list, the NumPy array is far improvised in terms of performance. NumPy array, okay, there it is a list array. It is actually not called as an array. We will call it just as a list, which is a data structure there. And here it is a NumPy array. It is going to be called as a NumPy array. Here in NumPy array, it's more easier for us to implement n dimension of data. N dimension of data. So you can make a note of it. The first thing is we have scalar data. Okay, you know what scalar data means. So when I say x equals 7, okay, this talks about scalar data. Okay, a single value. The second is vector. Okay, vector data. So vector data will be like this: 1, 2, 3, 4. Okay, in a row perspective, or it could be in a column perspective: 1, 2, 3, 4. But this is exclusively in one dimension. If you notice this, the data what you're seeing right now is completely in one dimension. So that's vector. And the third is matrix. Okay, and you know what matrix are: rows and columns. Okay, let's say 2 cross 2, 2 rows and 2 columns. The fourth is tensor. Okay, so anything which crosses beyond the third dimension, okay, then it is going to be a tensor. So it could be a 4D, or it could be 5 dimension, I'm sorry, 5 dimensions, or it could be 6 dimensions or 7 dimensions. So it goes till n dimension. Okay, so scalar, vector, matrix, tensor is all going to be handled with NumPy itself. The performance is going to be high when compared to Python's list. You're getting it? So looking at this, the performance wise, NumPy stands first. And also NumPy has uh, the memory management. The next important advantage is memory consumption. The memory consumption is going to be pretty less in NumPy when compared to Python's list. Okay, so let's say, for example, if Python's list is going to take 28 bytes of memory, okay, for a particular integer value. Let's say I have an integer value called 2. For that 2, the memory consumption is going to be 28 bytes, wherein in the NumPy, it's going to be pretty less. It might take only 8 bytes, okay, or it might take only 16 bytes. So the memory is going to be pretty less. The consumption of memory is going to be pretty less in NumPy. So two things: one, the performance; two, the memory management, the memory consumption. Okay, and third one is It has a internal iterations at the max. Internal iterations. What I mean by internal iterations, I'll show you through the code. This will reduce your lines of code in NumPy when compared to Python's traditional list. Okay, lines of code will be less. So if I'm going to invest some 6 lines of code in Python list for doing some manipulation, here in NumPy I'll be using only 2 lines of code. So hardly we are reducing 4 lines of code using NumPy. So NumPy is a library which is actually used to work around with your n dimension of data. Keeping in mind that n dimension of data is very important here. Can't we work with that n dimension in Python list? Of course you can do it, but it's going to be pretty hard in order to code them. Okay, you have to invest too many lines of code in order to work around with n dimension of data when compared to the NumPy. So keeping in mind performance, memory, internal iterations, which helps us in reducing the lines of code. So if you have any questions till this point, you please raise your query. I'll just pause here for 2 minutes of time to take up your queries. If you have any queries, please let me know. You can throw your queries on the chat box. Okay, so I guess there are no questions right now. So far, there were no challenge in my audio and video, I guess. So everyone would have got the concept of what I've explained right now. So let's go straight into the code. So the code that we had, I'll just give you a code by code explanations, okay, so that you can understand the flow well. Okay, so the first thing is the comparison. We are trying to do the comparisons. The first comparison is going to be with the Python list. So that's what is the function that we have created. I mean that I have created and I've posted on the group 2 to 3 days back. Now in this Python list, if you notice, the lines of code is going to be more when compared to the NumPy lines of code. So let's go ahead and create the function called Python list, and I'm trying to sum up. I'll give you a briefing about this. This function is exclusively for creating a couple of lists and sum them up. Before summing up, I'm trying to perform some squaring and cubing values. I will square it and then I'll cube it and then I will sum it. 3 steps are there involved in it. One, we will have list 1, list 2, list 1 will be squared. Okay, list 1 will be squared and list 2 will be cubed and list 1 will be summed up with list 2 and produce a list 3. These are the 3 steps. Step 1, step 2, step 3. Okay, list 1 square it, list 2 cube it, list 1 and list 2 need to be added, summed up, and then produce it. Okay, the first thing here is, let's go ahead and declare the list variables. Python list 1 equals, we need to convert it with a conversion function called list function. List is a standard function available in Python standard library. So we are going to use the list function. In that list function, I'm going to forward a parameter where I'm going to generate a range of values. So I'm going to use an inbuilt range function to produce a range of values. So let's say 2000. For 2000, I'm going to produce a range. Now, if I want to print this, you can do so. Print of Python list 1. Just come out and then give a call to this function and see what's the output of this function is. So this is the output. If you can see, it's predominantly we are working with too many number of datas. So what is the total number of datas that we have here? Is 1999, which starts from 0. It's in a sequential generation of numbers. These are not random numbers. Okay, these are sequential flow of numbers starting from 0, exclusive of the end value. So to have the inclusion of the end value, let's change it to 2001, and so you will see the end value will be of 2000. Okay, because always in the range, the end value will be, or the end point will be n minus 1. Okay, the given, from the given value it will be minus 1. So I'm giving the range as 2001. It has created 1 to 2000. Okay, to be more reasonable, let's carry some reduced less number of sequence of values, so that it will be easier for us to understand the concept. Okay, so this is what is list 1 is. So we have created Python's list 1, and we are going to create another list. In this, we are going to say list of range of 10 again. Okay, so both are going to carry a similar range of values. So Python list 1 and list 2 are going to carry the same number of elements, and the sequence is going to be same. But what we are going to do here is, post declaring the list elements to the variables, we need to have third variable, that is Python list 3. Okay, so it's an empty list. So as I said, create list 1, create list 2, square the list 1, cube the list 2, and then add the list 1 and 2 and store it in list 3. So here, how do we do that operation? Here where we need to go for order of n. Okay, we need to approach with order of n. So I'm going to use order of n approach here. Since it's a single for loop, I'm going to use in here. The order of n will be followed by initiating a for loop for I in let's say range, or I would say Python list 1. Okay, you can say Python list 1. Okay, you're going to find the range. The range is more or similar to the index only, so we don't need to convert them further to a range. So you can see 0, 1, 2, 3, 4 is all the element values. Index position is also 0, 1, 2, 3, 4. Please be noted, index position and the element values seems to be more same here. Okay, there is no difference in it. So that's the reason I'm going for direct of using for I in Python list. So capturing the values as an index right now. Now inside the for loop, we can use the Python list 1 of I. So what does it mean? I'm referring to the index. Index 0. Zeroth index is actually the value. So we apply the 0 here. It's a 0 index. In the 0th index, we are going to do the I squared. Okay, the value will be squared. The given value will be squared. So 0 will be squared, 1 will be squared, 2 will be squared, and it goes on. Similarly, the range of the Python list 2 is also similar. So we are going to use I, and this time it's going to be of I cubed. Okay, instead of I squared, we go for I cubed. Now the manipulated value, okay, the manipulated value will be updated back in the respective list. So what will be 0 squared? 0 will be 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, okay, 4 squared is 16. So it goes on. I mean, whenever we are having the manipulations here, these manipulations are not just for standalone manipulations, it's for reflecting back in the respective list. So once this is done, now we can go for capturing the Python list 1 and list 2 in a summed up manner, and then store it in a Python list 3. So we have Python list 3, and I'm going to use append method in the list. From the list, we use one of the algorithm called append, and in that append, we are going to forward the Python list 1 of I plus Python list 2 of I. So the thing that you have to notice here is we access them only through index here. You cannot directly do plus. Okay, you cannot just say list 1 plus list 2. What will happen when I say list 1 plus list 2? It will just concatenate. It will just concatenate. Please be noted. Okay. When I'm saying list 1 and list 2, it will just concatenate, but it is not going to sum up the values. That's what is the drawback that you will see in Python's standard list data structure. But in NumPy, when I have two lists, when you say list 1 plus list 2, it will do the exact summing up of the elements. So 0 plus 0, 0, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6. But what happens in Python? It just prints 0, 1, 2, 3, 4, 9, and again concatenate with 0, 1, 2, 3, 4, and 9. So that's how the flow will be. Okay. So it's better to use NumPy in that situations while we are handling with a large number of data sets. The data sets should be of large number. Now we can return this. Return Python list 3. Okay, so that's all. Now if you have any questions on this snippet of code, you can raise it on the chat box. I'll try to give you more clarity on it. Okay, no hurry, we can go slowly. Okay, nothing in hurry here, because the understanding of concepts are very important. So we will catch it up again frequently in the next week also, or whenever I'm free. I'll try to come up with more evening time of schedule, so we'll connect up and see, we will get more understanding of the concepts in detail. Why we use append? Okay, the reason I'm using append is to take the value, because uh, you're not going to position it out here. Okay, Python list 3 of I 0, 1, 2, 3. You can do that as well, but instead of having that indexing positions for list 3, you can go for a direct function called append. It keeps appending it, the element. Okay, the first time it's going to be 0 plus 0. Okay, and the next time when it has become 1 plus 1, let's say it's going to be 2, so 2 will be appended. So 0, 2, 4, 6, 10, it goes on. We need not manipulate through index at that point of time, because we have an effective function called append. See, logic can be anyways. See, this is not the only fashion of code. You might have different logic. Okay, but I'm following this standard of code. Okay, this is I'm just following the standard of code. That's all. Return statement. This return statement is mandatory. We are not storing it in caller. Yeah, return statement is mandatory because see, the idea here is I'm going to return this value and I'm going to manipulate it later. Probably I might be printing it. I might be collecting the result. So Python, let's say result. Okay, so I'll do this. So it's good to have this return, and later you can manipulate with that Python list 3 elements in different ways. So this is the function implementations, and let's go ahead and print the Python result. So you can see that it works as desired, right? So 0 squared is 0, 0 cube is 0. So 0 plus 0 is 0. Okay, 1 squared is 1, 1 cube is 1, 1 plus 1 it's 2. Okay, then we have 3, right? So 3 squared, uh, I'm sorry, 2. So 2 squared and 2 cube. Okay, 8, 8 plus 4, 12. Okay, so it goes on. Then 3 squared and 3 cubed, 36, 80, 150, and so on. So it works as desired. Great. This might be a piece of logic. This might be a piece of logic. But what I wanted to show you here is the most important thing that we have to figure out here is how much time does this function is going to take? How much time this function is going to take in order to manipulate this this logic? That's what which we are going to see right now. Okay, so I have created a function. I've made up with some set of codes. Now you can go ahead and call this function. While calling this function, okay, I'm not going to worry about the result. Okay, right now I'm not going to worry about the result. Okay, only the operation time that's taken by this snippet of code is what we are going to calculate. In IPython, interactive Python, we have something called timeout. Okay, you can use percentage timeout. This percentage timeout will calculate the time taken by this particular loop while you execute this particular function. Okay, so I've executed it. You can see while you call the function, prior you call the function, you need to apply the percentage timer. This will automatically start tracking the time taken by this function to complete its execution, which includes your for loop, the manipulative code, okay, and then the number of times the loop is actually executed, the average time the loop is executed, how much time the loop have taken to execute, will all be evaluated. So you can see the shorthand result here. Okay, the shorthand result, you can see it is uh, nanoseconds, 59.4 nanoseconds approximately per loop. Okay, per loop. Then it is also giving you an average microsecond. Okay, 8.32 microsecond is what is taken, and in that 8.32 microsecond, 59.4 nanosecond per loop. So per loop iteration, it has taken 59.4 nanosecond. Overall average time, which it is saying is as 8.32. These are average only. Okay, you can see it's only on the mean level. Okay, it takes some sampling of number of times it gets looped. Okay, but actually it's good if we go ahead with more number of loopings. So here I'm going to say 2000, and here again 2000. Okay, now let's see how much time it's going to take. So we have to wait for few seconds in order to get the result. The result which is produced will take time because it has to evaluate and then generate the report. So you should not think that it is taking some time to produce the result. So is that it is taking that much amount of time to process? Not exactly. Okay, it is taking some time to generate the report. Okay, so time it might take some certain time of uh, operations. So that should not be considered here. The output is what we need to consider. So 1.77 millisecond, before it was microsecond. Okay, before it was in microsecond, but now it is in uh, uh, I'm sorry, millisecond. Here it is in millisecond, ms, you can see. Okay, and the per loop was in nanosecond, but now it is in microsecond. Okay, you can see that it becomes as a microsecond. So you can see the difference. It's slightly increasing. It's slightly increasing because the number of loop got increased to 2000 elements we have. Okay, so it has to iterate for 2000 times. So that's the reason the time is increased. Great. Now let's go straight into the NumPy code. So in NumPy, how the code is going to be. I've already shared that code. So we declare the function. Now this time it's going to be NumPy array sum. Okay, I'm not going to call it as list. Instead, I'm going to call it as array. Here it is a Python list sum, and here it is a NumPy array sum. Now inside this, I'm going to declare the similar version of variables. NumPy array 1 equals. Now notice previously we used range function. You can see here, right? This range function is a standard Python function. Range function to produce range of elements in a sequential order. But here, what we are going to do is we are going to use NP object, NP library, okay, NumPy library dot a range, array range. It's a special range function which will be used from NumPy. Okay, NP arrange, or you can shortly call it as arrange, array range. And in this, you can drop the similar number as 2000. And again, you can carry another variable called 2 and NP arrange 2000. Now see, I said there are three advantages. One, performance will be greater, memory consumption will be lesser. Third one is internal iterations. Internal iterations will happen. So that is the most important thing that you have to be pointed out, because I'm not going to use for loop like as we did in standard Python code. Okay, using NumPy, it's going to carry an internal iterations for all the 2000 elements while we are generating. So I'm going to say the squared here and the cube here. Simple. That's all you have to do. Okay, in the line of np.arange of 2000 squared and cube is done. This is only for reducing the lines of code, nothing much to say here. And you go for the Python 3. But if you look at the I'm sorry, numpy array 3 variable, a new variable which we are going to declare, and this variable is going to carry numpy array 1 plus numpy array 2. That's all you have to do. Compare it with the previous line of code, similar lines of code that we have written in standard Python code. What we are doing here, Python list 3 append access through the index. Only then you can do the sum values. Otherwise, it will only perform a concatenation. But here, you will use numpy array 1 and numpy array 2, which is going to completely sum up the values directly without the indexing order. So somewhere it is doing an internal iterations here, right? So only through indexing you can get the value, okay? And then you can concatenate it. I'm sorry, you can sum it. But here, without an indexing, if it is happening, then there is a internal iterations which has taken place. That internal iteration is actually helping us in reducing the lines of code from not investing these for loops explicitly. Explicitly, you need not write the for loop. The NumPy array can enable the internal iterations wherever the manipulative codes are written. This is a manipulative code because we are trying to sum up a couple of arrays, NumPy arrays here. So let's return this NumPy array 3. Okay, so we have written it, and you can call it and see what's the output of this. NumPy result. Okay, shortly temporarily we'll just reduce the number of elements which we are comparing with the Python's standard list operation with NumPy's array operation. So we need to call this function print the NumPy result. Is this the same output? Yes, of course, it's the same output as like what we have seen in the previous standard Python function that we have written. Here it's a NumPy array sum function which is producing the same result. But see the lines of code that we have invested here. Number of lines of codes are pretty less when compared to the previous Python's standard operation of code. And more interestingly, we can also see that the time taken. So we are going to see the time taken by time it. Okay. Let me execute this first and then this. See the difference. Okay, I guess I have to increase. This is with 10, right? Should be 2000 because there we are evaluating with 2000. Here also it should be evaluated with 2000 elements. so that you can go ahead and execute and see the exact difference of time taken by both the logic of code. So this is showing it as 1.77 microsecond, and the per loop is 130 uh, millisecond. Here you can see 14.3 millisecond, 679 nanosecond. Predominantly, you can see the performance is higher in NumPy array sum when compared to Python list sum. Hope you are getting the concept. Okay, so this will ideally prove that the numbers what is shown here is actually higher when compared to the numbers that's shown with the NumPy array sum, because it's dealing only with your millisecond and nanosecond. Here it is with microsecond and with millisecond. Per loop itself is millisecond, but here per loop is just nanosecond time. Okay, if you have any questions on this differentiations, please let me know. Logic is all the same, the output is all same, no difference at all. There is no difference. Okay, the code number of lines of code is reduced, and we are introducing a NumPy library into it, and the performance can be seen that NumPy n dimensional array overtakes your standard Python list. Yeah, those you have a concatenate method. Okay, in NumPy also you have a concatenate method. Deliberately we can work out in that way to concatenate a couple of matrices. Okay, you can do a concatenation of two scalar values, I'm sorry, the vector values or a matrix values or a tensor values can be done. Okay, because plus operation is entitled to perform only some values, not concatenation. So do anyone have any other question? Please let me know. Yeah, so why it is happening 1,000 loops each is because if you see the difference, actually here we are deliberately using an explicit loop here. Okay, so this is for single 2,000 times that operations are happening here. But in this case, we are increasing it. You can see that a range, you are not using an explicit for loop here. It's using an internal for loop. So for every internal for loop, the number of iterations are getting increased. So in that case, obviously your evaluation for the performance will be on top of higher number of loops. But here the order is, as I said, order of n. It is only order of n. But here it is not order of n internally. So we don't know how many number of for loops that it is internally using. So it will overall it will keep it in a higher base of looping executions. So that's why it is giving an 1 lakh loops each. This 1 lakh loops each means it is not that it is executing for 1 lakh loops. It is keeping the benchmark as 1 lakh loops, but it does not go to that end of 1 lakh loops. Fine. So here, I guess you can just shortly see this 10 and 10. Okay. And I'm trying to print this array. So you can see there's a concatenate function, and use this NumPy array 1 comma numpy array 2. So you can see this. So by this way, you can understand 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And again, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we are approaching here is concatenate. Concatenating two NumPy array. Okay. But plus will not concatenate. It will only sum up the values 0 plus 0, 0, 1 plus 1, 1, 2 plus 2, 4, and so on. Okay. So we have a deliberate function called concatenate in order to apply that operation. I guess this gives you a clarity. We can discuss more number of functions. There are hell a lot of functions are there in NumPy. Okay, so we have to go slowly, but the answer is yes. Can we concatenate a couple of matrix? Yes, of course we can do it. Can we concatenate a couple of vector? Yes, of course we can do it. So the answers are yes there using this concatenate function. Fine. So still have another 40 more minutes. Okay. So what are the two things that we experienced from NumPy right now? You got an understanding that NumPy is faster. NumPy arrays, n-dimensional arrays, NumPy n-dimensional arrays are faster. Okay, faster when compared to the Python list. And we also observed that the lines of code that we invest in traditional Python list manipulation is higher when compared to the NumPy. NumPy manipulative code is going to be less, but Python standard manipulative code will be more. So hardly we are reducing it to 50 percentage or to 60 percentage of lines of code. Not always you can reduce it to 3 or 4 lines. Sometimes we need to apply the logic deliberately. So it needs certain lines of code which is more similar to what we write in the Python standard code as well. So we can say 50 to 60 percentage of code will be stable in NumPy, but still you can save 40 percentage of code. You can reduce 40 percentage of the code. Okay, what is the next important thing? Memory consumption that we have to visualize and understand so that we get the confident, yes, NumPy is a better library for working around with data sets when it comes to the data science field. So memory consumption. So how do we learn this memory consumption concept? We'll see that now. So here we'll take another new notebook. Okay. So we go ahead and the first line is import NumPy as NP. Go for the new cell. Here we need to find out uh, the size that's going to be consumed by Python list, the number of elements that you're going to use in the list will be calculated for its total number of memory consumptions. So how do we track this? We will go ahead and declare the list here, our Python list of range. Okay, I can say 10 again here. Then we are going to have NumPy list 1 equals, here we are going to use np dot a range. Please remember those functions. There it is range, here it is a range, which has to be called on top of the library name, and here you're going to say 10. So let's go ahead and print them to see what are the values that we have in the particular list and array. NumPy list 1. So you can see that these are list of elements. You can see the comma is there, but these are uh, vector elements. Okay, so you will not see those comma there. Okay, no comma there, right? To be a notable point here, there is no comma in the elements, but there the segregations will happen with applying a comma to separate the elements in the traditional Python list over NumPy array. Now I need one more library called sys, which referring to the system related functionality. So import sys is required. Let's execute that. Now what we have to figure out here is the size of these elements. Size of these elements have to be tracked. So first let's go and see the size of this Python list. How to track the size of this Python list. So let's say memory consumed okay equals, we are using the sys library. Sys dot get size of method is there. We have a method called get size of. This get size of will get you the size of some random integer numbers. So let's say I put some number like 7. Any integer number, it's fine for it. To be more precise, first you have to understand what it does actually. So let me go ahead and print. Forget about this for a while. System dot get size of the number 7. So what is the size of the number 7? It's an integer number. The memory size is 28 bytes. 28 bytes. Okay. It's not bit. Okay. It's bytes. Please be noted. 28 bytes. Right. But the same integer number, if I'm giving 0, it's going to be 24. So this is considered by Python memory allotment. Python's library, standard library memory allotment for a numerical number for 0 is 24 bytes. Okay. But if it's greater than 0, or let's say I'm giving a negative number, okay, or positive number, right, it's going to be 28. But for 0 alone, it's consuming it as a 24. They might have a different principle for that. I'm not sure that why such exact number of size have been utilized for 0 and other positive and negative numbers, but they have their own principle for it. But they work on top of this 64-bit Python environment, okay, or 32-bit Python environment. Accordingly, the size might vary. Okay. So now coming to this understanding, what you're getting to know about is the size of the particular numerical number. Okay, great. So we have this now. Now the next thing is I want to know the length of the array. So length of this, you might be much aware of it. Python list, it will say 10. Okay, so you know that length is 10 and the size for one integer element, the size for one integer element is 28 in that case. So we do have 0 here. Okay, so let's go ahead and this is just a 0, so the calculations might be different. We will go ahead and apply the formulae as multiplied by length of Python list 1. Okay, so now we can print the total memory that's been consumed. 280. It's known because you have how many elements? 10 elements. Okay, the 10 elements is multiplied with 28 actually. So actually it should be 1 is 24 only, right? So minus 4, you can add it up. Minus 4, so it's 276 actually. The total number of size for this particular memory size for this particular array element is 276 bytes. 276 bytes. Okay, that's what Python, traditional standard Python list is consuming the memory as for 10 elements of integer. For float, it will vary. For string, it will vary. Okay, now we are only talking about the integer. So one example is sufficient to understand the difference between NumPy and the Python traditional list. Now let's go ahead and apply the similar concept of code for NumPy array or NumPy list. Okay, NumPy list 1, or let's call it as more reasonably as array 1. Okay, now here it's going to be slightly different. What we are going to do right now is we are going to find the item size and the size. Item size and the size. Okay, we are going to find out the item size. That is NumPy array 1 dot item size. Okay, NumPy array 1 dot item size. It will take some time actually. The auto intelligence will take some time because there might be too many function attributes and functions are there. So first let's figure out the item size here. Print of NumPy array of item size 1, item size is going to be 4. Okay, because it's an integer, it's considering it as an integer, and the integer is going to take, one integer element is going to take 4 bytes. Okay, so as you can see here, please understand that 4 bytes. Okay, the reason why it is 4 bytes, I'll tell you. The reason why it is taking 4 bytes is this range can have a range can have a D type. Okay, D type means data type. Okay, D type equals np dot int. So it's 4 bytes. Let's say 32, int 32. Okay, I'm declaring it as an int 32. This is what is the power of NumPy. You can choose the exact integer byte elements so that your memory can be easily controlled, because the numbers are only the 0, 1, 2, 3, 4, 5. So 2 till 255 numbers. Okay, when you take a numerical numbers till the order of 255, negative 0 till 255, it's enough to work with int 8-bit systems. You don't need to go for 32-bit system. You can just go with 8-bit system, right? So I can say the data type as int32. If it's, let's say 64, if I'm consuming 64, see it's 8 bytes. It's 8 bytes. Okay. So what does it mean? The int 64, the 32, which is doubled. So it is taking it as, before it was 4, now it is 8. So 8 bytes, what it represents, when you calculate for the 64, or let's say 32, okay, 8 plus 8 plus 8 plus 8, okay, 16, 32. 32 bit, now it is 64 bit, so you need plus 4 more 8s. 8 bit equals 1 byte. Universal fact, 8 bit is 1 byte. So 32 bit system means it's 4 bytes. Okay, if it's 64-bit system, it is 8 bytes, right? But so the memory is more. The memory is more. So now it is in 64. I'm considering it as an in 64. So let's go ahead and execute this formula. Now you can find out the item size and multiplied with the length. Length will be found by using a special attribute called size. Okay, size will give you the number of elements that's there. As like we got the output from the length function here. Okay, using the length function, we got how many number of elements? 10. The same way here, it's going to return 10. So 10 into 8. 10 into 8 NP array 1. How much bytes? It's just 80 bytes. Okay, wherein here it's 280 bytes. For the same thing, Python memory allotment is 280 bytes, whereas here for the entire 10 elements, it's just 80 bytes. So which one will you prefer now in terms of handling enormous number of data sets? Obviously, we go for the NumPy library. And it's more convenient for us to work around with the dimensional of data. So I can further reduce this. This 80 bytes can be controlled. I can just give 32. If I give 32, it's still 40 bytes only. I can even go to 16. Okay, 20, 2 bytes per element. I can go for 8-bit system, 1 byte. 8-bit means it's 1 byte. If it's 1 byte, then 1 into 10, it's just 10 bytes. But here it's, for the same 10, it is occupying 280 bytes. So we don't have that control. But in NumPy, you have the feature of controlling the data type by using these int 8, 16, 32, 64. For the float, you will have 16, 32, 64, and 128. For float data type, I'm saying float 16, float 32, float 64, and float 128. These are the different floating type that you can use. And for integer, it is int 8, int 16, int 32, and int 64. So complete control is there in terms of NumPy when it comes to the memory consumption as well. If you're aware of the data type, then damn sure that you can quite reduce your memory consumption down there. There is a meaning. Is this clear now? If you have any questions related to this memory consumption, please let me know. What's the max value given X elements to range function for list and rearrange function for array using it? I'm not getting your question. See, you have to provide the maximum range here. Okay, you're talking about what is the max that can be of I'm not sure about the actual max range, but it depends on your system's memory. That's what always Python says. Python's environment says the limit is based on your system's capability. You can store as many number of data and you can produce as many number of data. Default type depends on the type of value that you drop in. Okay, this is a range will always I'm sorry, a range will always work out in terms of integer only. Okay, this is not a random generation numbers. So by default, it's going to be considered as an int. Okay, it was showing 4 at that time. So means it was consuming it as a int 32. Int 32 is the default. Is that clear? Yeah. Do anyone have any other question? So please be noted the style of code that we are writing here. That's important. Here we use systems get size of to get to know the size and then multiplying it with the length. And then here we are using an item size and the size attribute. Okay, item size attribute and the size attribute in order to capture a particular item's size and the total number of elements in that array will be captured with the size attribute. Okay, so that's so when you study NumPy, now you will be very clear that why you need to go for NumPy. Because if you go for any interview, a data science related interviews, as far as that I've researched on the blogs, NumPy related interviews will be based on this. First question that they will ask is why we need to go for NumPy when all possibility of features are also applicable in the Python data structure itself. Python standard library data structure, standard libraries data structure. We can achieve that. You need to remember these points with the demo I've explained. I'm not just giving you a theoretical understanding, I'm giving you a practical understanding. So, this you need to understand it in detail and say the number one is the performance, number two is the memory consumption, number three is internal iterations, so that the number of lines of code can be gradually reduced. Okay, it can be gradually reduced. If any queries you have, please come up. Because this is not a, a professional session. Okay, I just created as a casual session, so you can come up with if you have any uh, queries or that is haunting you. Please come up. Even if I'm not aware, probably I'll try to catch up the answer later and I'll give you. But raising questions are very important. Only then we will learn a lot. We have to raise questions. What will happen if this is given? What will happen if that is given? So why can't we work this way? A dummy question might be here. Okay. So what will happen in this case? It's going to be 280 again. Okay, but the idea is not to capture the Python's memory allotment. The idea is to capture whose memory? NumPy's item size memory. Okay, so that's why I'm using that attribute while manipulating with the number of elements. Okay, so like this is an example I'm saying. So we need to come up with a lot of questions. Of course, you can use it for binary data also. Okay, it is also possible. You also have unsigned integer data to be used. Uint is there. Okay, there are different data types. I will try to post those informations on the group so that you can take it up from there. So strings will be actually internally represented as a binary in NumPy. String data will be represented as binary internally to the NumPy. That itself is uh, one real-time understanding of binary handling in NumPy. Okay, thanks for your questions. And now let's see. I guess we still have another 15 more minutes. So we'll try to get into a little more understanding of NumPy. Let's create another notebook. Okay. Now the concept is fine. Okay. We understood that why we need to go for NumPy and everything is fun. NumPy is going to handle an n dimension array and so on. Let's try to manipulate the creation of array. We were only using range. Now we need to see how to create an custom array elements in NumPy. Okay, so how we are going to do this? The first one is np first is import NumPy as np, Okay. Now np dot array function will help you to create an array of elements. Please be noted. Before we were using np dot a range. A range is array range. But here it's np.array function. This np.array function will take in an input of list elements. You can see the square brackets. It's a list elements 1, comma 2, comma 3. Okay. And you can store it in one variable. Let's say np array. Okay. np array. And you want to find out the dimension of this array. Okay, you want to find out the dimension of this array. So I can use np array dot ndim attribute. With this ndim attribute, you can get to know the dimension of this array. This is what dimension? One dimension array. One dimension array meaning is it's a vector. Do you all agree? It's a vector. Okay, it's not scalar. Scalar means it's a single value. If you say 1, if you say 2 alone, it's a scalar values. But right now we are on the vector. It's a one dimension. But the same one dimension we can increase to a multiple dimensions as well. So let's say, for example, if I'm printing this, print np array. Okay, you can see that it's a one dimension. I'm giving comma and I'm giving the next element 4, 5, and 6. Okay, now you will see there is an type error occurs. Why this type error occurs is you're enforcing a couple of list elements into an array creation, means you need to refer it as a dimension of second order. So to make it as a second order dimension, I need to embrace it within another list of syntax. So inside a list, you're having a list of list elements. Inside a list, you're having a list of list elements. Now it is accepting. You're getting it? So if it's a vector, vector, you should have only a single list. If it is a matrix, then you need to have multiple lists in another list. In another list. What is the dimension now? The dimension is 2 dimension. Matrix are 2 dimensions, right? So now we are representing this. Okay, we are representing this. It's a it's in terms of I'm sorry, this is a third dimension. Sorry. So here we are representing this 2D. Okay, rows and columns. So how many rows and how many columns are there? 0, 1. So it is 2 rows and 0, 1, 2. Okay, so it is 3 columns. You can see. Okay, rows and columns. Rows and columns comes into the picture while you're working in terms of matrix. Okay, the cubes, you can see this is a cubes. These are 3D or it could be ND. From here you can create a cube of cube, cube of cube of cube. Okay, so it goes to any depth. How we can confirm that it is a single dimension or one dimension? By looking at the flow of the data. At the end, if you see 2 square brackets, okay, at the end, if you see 2 square brackets, it's 2D. At the end, if you see only 1 square bracket, it's 1D. At the end, if you're going to see 3 square brackets, it is 3D. At the end, if you're going to see 4 square brackets, it's going to be 4D. A shorthand way of considering the dimension of that array. Okay, it's only a loophole that I'm finding in order to find out the number of dimension. Okay, now what I'm going to do is I'm going to upgrade to the 3 dimension. So how to upgrade it to the 3 dimension? Another list of list. Okay, you need to comma and put it like this. Another list of list, but that need to be enabled in another list of order. Single outside, it should be a single list appearance. Okay. Now at the end, you can see how many square brackets are in closing. Closing square brackets are 3. So this should represent a 3D. Okay, this represents a 3D, 3 dimension. Okay, so how it looks like, say 7, 8, 9, 10, 11, 12. Okay, so if you look at this, the cube which I've drawn just now, okay, so that's what is the appearance of this 3D is. But if you look at the 3D here, okay, this is one uh, apartment, okay, or let's say this is one apartment, the whole apartment. Okay, in that whole apartment there are two floors. Okay, there are two floors, 0th floor and first floor. So what the 0th floor and first floor says, 0th floor and the first floor says that it is the 0th uh, the slice, okay, and the first slice. Then comes your in the 0th floor of this apartment, okay, you have the number of apartments splitted into two rows and three columns. So you actually have six flats in it, six flats, six individual flats. In the first row, three flats, and the next row, three flats. Okay, and that is considered as a three columns in it. And the first, I mean, in the first floor, you have uh, three flats in one row and three flats in another row. This assumption, okay, this assumption can help us in understanding how the 3D is represented, but we can't go for understanding of 4D or 5D. Okay, it will take some time for us to understand quickly. We cannot understand it, but we can also go for 4D, you can also go for 5D appearance, right? Now in a matter of time, okay, in a matter of time we can use this function called flatten. What this flatten function does is the created dimensions will all be brought back to your single vector. Okay, the 3 dimension right now is brought back to the vector mode. Okay, you can flatten it. See how easy it is. Okay, any dimension order, but still you can bring it back to a flatten of vector. No problem. It will quickly bring it. Now, how do you find the type of it? Print np array dot d type. You have d type. What the d type says, what is the default type? Int 32. Just now I referred that, right? So using d type, you can capture the int 32 by using a function called flatten. You can flatten it. Ndim will refer the dimension. You can also get the shape of this dimension. Okay, forget about the ndim. Okay, you can also find the shape. Dot shape. So what does that shape says? Okay, you have two slices, two rows and three columns. You're getting it? Two dimensions, right? I'm sorry, uh, two slices in the cube, and in each cube, two rows and three columns. So 2 comma 2 comma 3. So the first one will always refer to slice. Second one will refer to the rows, and third one will refer to the columns when you are trying to define the shape of this particular n-dimensional data. Okay, we are only figuring out in what are all the ways that we can quickly get the metadata informations. These are metadata informations. N dimension, shape, D type is all giving you a metadata information about that particular ND array. Metadata. So metadata means what? Data about data, correct? Data about data. So we are only capturing the data about data by these attributes or the functions. Now, one last thing that you can notice here is, please remember this D type is not the data type of this object. This object's data type is not integer. Please be noted. The elements that's there inside this object, okay, this is an object, and inside the object you have all these elements. Okay, These elements data type is what is integer is. But this variable data type is what? That's a question that we must have. And the answer for that question is print, as usual as we do in Python, by finding the data type of a member by using the type function. There you can drop in this variable and see what's the type. As I always saying from the beginning, that's an ndarray. So NumPy produces, okay, NumPy produces an ndarray object. Ndarray is an object. Ndarray, NumPy ndarray. To know more about it, we can say print of let's say help of np dot ndarray. Okay, so what is this ndarray is? Ndarray is a class. Ndarray is a class. We are creating an object for that class. What ndarray carries in the constructor of the ndarray? Shape, okay, data type, okay, the buffering, okay. So examples are given here. Data type, you can refer it as float, offset values, okay. uh, Default is float actually here, okay, but the element what we have given is integer, so it is considered as an integer. So an array of object respect to a multi-dimensional and homogeneous. That's very important. Homogeneous. NumPy array is main focus. NumPy's array main focus is homogeneous of data. Homogeneous of data. We have 4 more minutes, so I'll not take more than that. Homogeneous data. So what do we mean by homogeneous data? Single type of data. Single type of data. But if you take a traditional, okay, if you take a traditional Python, you take a traditional Python list is not homogeneous. They are heterogeneous. Heterogeneous of data capturing will happen. Why? Because in a list, you can have integer, okay, and suddenly you can have a Boolean value, okay, and suddenly you can have a string value, right, and suddenly you can have a float value, okay. So it's going to be heterogeneous. But here NumPy's main focus is homogeneous. But NumPy homogeneous can be manipulated to heterogeneous, means you can convert the homogeneous approach to a heterogeneous approach also. We will see that more in detail probably next week. I might come up with another session. So there we'll be seeing more advanced discussions of this NumPy. At the time, you will get to know how to convert the homogeneous appearance of a NumPy to a heterogeneous. But default NumPy main focus will be on homogeneous set of data rather than heterogeneous. Is that clear? So ndarray, what is the outcome of a NumPy? Please be noted. What is the outcome of a NumPy array function? Is nothing but an ndarray object. Ndarray object. Ndarray is a class in NumPy library. Okay, you can get the help of that and see what is the actual details of that. Okay, I'll stop here. I'll take a couple more of queries if you have, and then we'll end up the session. If you have any questions, please come up. This is only a beginning. We have just taken a step one. Okay, let's go with a baby step. No worries. Let's go with a baby step. So step by step, let's uh, enhance our skills. But you need to constantly work on this. That's very important. Okay. See, it's a win-win situation. You might ask, sir, why is that you are giving a training for us? Okay, you can ask. Uh, I'm coming up with all these trainings as a free of cost. Okay, why am I supposed to do it? It's a win-win situation. One, I'm learning again. Okay, I'm learning it again. Two, you're getting learned from me, and you're throwing more questions, and for that I'm trying to respond. If not, I will rethink on that question and try to figure out the answer for it. So it's a win-win situation for both of us. Okay, so that's so what I what I want to conclude here is you have to practice. Once this session is over, please Take it as a practice. Casually go and do meddle with some data, do some different manipulations of dimensions, and try to work around with that. See what all the different functions are there. Start triggering conversations relevant to that on the WhatsApp group. So that's how we get. That's how we stay motivated. Okay, because data science field is a quite large field. So entering into it will take some time. Patiently, we have to upskill ourselves, but at the same time, we have to be little faster as well because we need to keep a specific deadline. You can have your own deadline. I'm not going to say whether you're going to complete it within 6 months or 1 year or 2 year. It's your own. It's your own learning curve. Okay, you can set your own goal. Okay, but keep driving towards that goal. Okay, don't get deviated. That's important. So from the motivational factor, I'm ending it.